Okay, so let's understand what is three-dimensional geometry. This is a very important topic. We have done all the introduction of this topic in the previous chapter, which is vectors. And of course, before you start studying this chapter, it is necessary that you go through vectors properly. It is important that you know vectors, because this entire chapter we are only going to look at vectors. The language that we will talk, everything that we will do will only be with vectors. So if you need to go ahead and revise a little bit of vectors, do that. And if not, of course, while we do the chapter, we are going to go through some concepts of vectors, and we will see them, correct? So first of all, in vectors, in exercise 10.2, we have seen what is direction cosine, and direction ratios. Direction cosine and direction ratios, correct? I hope all of you remember, we have done this in the last class, right? Okay, let's understand once again. Suppose if this is your y-axis, this is your x-axis, and this is your z-axis, right? Let's take P is any point here, okay, and the coordinates of P is x, y, and z. All right. We all know the line that joins from the origin to P. We call it as the position vector of OP. This is O, origin, and this is P, correct? One more thing we are all aware of, that we saw in the last in this particular topic, is that this position vector makes an angle with every axis, that is the positive side of x-axis, the positive side of y-axis, and the positive side of z-axis, correct? This angle here we call it as alpha, this angle here we call it as beta, and this angle here we call it as gamma, correct? Remember, we had seen this. Now it is only with the positive side of the x-axis. Then the direction cosines. What are the direction cosines then? Therefore, the direction cosines of OP vector. What are the direction cosines of OP vector? They will be cos alpha, cos beta, and cos gamma. We have seen this in the last lecture, right? Now consider, suppose this is equal to L, this is equal to M, and this is equal to N. Okay, see, next time when we mention L, M, N, you must understand that we are talking about cos alpha, cos beta, and cos gamma. Every time now cos alpha, cos beta, and cos gamma will be mentioned as L, M, and N. What is L? L is with respect to angle with which is made with x-axis, correct? Angle made with x-axis. What is M? It is angle made with y-axis. And what is N? This is an angle made with z-axis, correct? So next time onwards we are going to call this as L, M, and N. Okay, what are the direction ratios? Direction ratios. What are direction ratios? Direction ratios we know are such three numbers, correct? These are such three numbers A, B, C, right, which are proportion, A, B, C, which are proportionate to what? Proportionate to L, M, and N. That means such that, how we can write them? Such that we can say L by A is equal to M by B is equal to N by C, correct? Direction ratios. So direction ratios are A, B, and C. What are direction ratios? Direction ratios are is equal to A, B and C. Getting it? Let's write down a little properly. A, B and C. Okay. Now, for any vector in the world, okay, see, what would you say? Suppose we have a vector. Okay, how do you write a vector? Can I say a vector is equal to x I cap plus y j cap plus z k cap? Correct. In this, the scalar components of these vectors are what? They are the direction ratios of this vector. Correct. The scalar component of this vector are the direction ratios of this vector. Are you guys getting it? Okay, so therefore can we say that direction ratios of a vector is equal to x, y and z, right? And direction cosines of a vector will be what? It will be x by magnitude of a, y by magnitude of b vector, no a, sorry, a vector, and z by magnitude of a vector. Correct. So we can also say that direction cosine of any vector is the scalar component divided by the magnitude of that vector. Correct. Can we say that? Therefore, what can we say? Thus, how can we how can we write it? Therefore, can we say that? Okay. Therefore, can we say that direction cosines of any vector will be scalar component of that vector divided by magnitude of that vector. Clear? All right. Now, okay. See, going back to this, okay, these are the scalar components, correct? This is the a vector and these are scalar components of a cap, correct? So r scale, see, okay, now let us see scalar component. See, we have, what are the scalar components of a cap? What would that be? A cap, scalar component of a cap. Let us find out. See, what is a cap equal to? Can I say a cap is equal to a vector by magnitude of a vector? Correct? Which is equal to x I cap plus y j cap plus z k cap divided by magnitude of a vector. Correct? So this can be written as x by magnitude of a vector plus, x I cap plus y j cap by magnitude of a vector plus z k cap by magnitude of a vector. Okay, so therefore if you remove the i's, j and k, then you will get the same. Correct. Therefore, what will you get here? So we are back to the same thing and we can say that x by magnitude of a vector we can say this is L, y by magnitude of A vector, we can say this is equal to M, and Z by magnitude of A vector, we can say this is equal to N. Getting it? Okay. That means we can also say, therefore, we can also say, so we can also say that A cap is equal to L I cap plus M J cap plus N K cap. Correct? Which means what? Which means if direction cosine of A vector are if given, therefore can we say that if direction cosines of A vector are given, correct, then we can also write a unit vector, correct, then we can also write a unit vector, correct. Unit vector, what is unit vector? A cap, correct. See, in this chapter we only talk about direction cosines, direction ratios, so it's extremely important that you understand vectors very well. If you don't understand vectors very well, this chapter can actually be a trouble for you all. Okay, so it's always better that you go back and check what is vectors. If you have not understood, we shall have the explanation, and then again you can do this chapter. All right. Okay, now let's go ahead. I hope until here everybody has got it. Okay, see, we have been seeing about vectors even in the last lesson. Let us now see what is direction ratio and direction cosine of a line. So this is direction ratio and direction cosine of a line. Okay, see, in grade 11 we saw that if a line intercepts, okay, if a line intercepts x-axis, then the slope of that line is tan theta. And what is tan theta? Tan theta is that angle which is made with the positive side of x-axis, correct, by that line. So suppose if we have, this is your x-axis, this is your y-axis. Okay, and let's take, this is the line, let's say this is line L. This line L is making an angle, say theta, with the positive side of x-axis. Then M, which is slope, will be tan theta. I hope everybody remembers this. This distance here is C. This distance here, C, means what? This point is C. Correct? This point is C. So understand, the parents of a line are slope and intercept. Okay, the sole parents of a line are slope and y-intercept. These are the my-bap of the line, correct. So therefore in the 2D form we saw that what is the equation of a line? Equation of a line will be, equation of a line in 2D is equal to y is equal to mx plus c. This was the equation that we saw in the Cartesian plane or 2D format, we can say, correct. But what right now what we are doing is not 2D, it is 3D. In 3D the line is in space, it is in the air, it is not in space, it is on a 2D surface. In 3D the line is in space. How does it say in space? Let's see, suppose this is your y-axis, this is your x-axis, and let's say this is your z-axis, correct. Now suppose let's take a line which is going to cross from here. If this is line L, Okay, this line L is in space. This line is in space, correct? Consider this line. This line is in space. You know, in space, in your room, in the room which you are sitting in, just try to see that you're keeping one line, like, you know, somewhere in the space. It is not leaning, it is not touching any wall, it is just in the space. Okay, and we have to find the equation of such a line. Now to find out the equation of this line, okay, this is what we have to do, equation of the line. So for convenience sake, what we are going to do, we are going to take this line, instead of keeping it here, I'm going to put this line and I'm going to pass it through origin, because if I pass through origin, things will become little easy for us, correct? Now how will it pass through? So we are going to take this line and we are going to pass it through the origin like this. Say, let us pass it through the origin like this. Okay, this is your line L. Okay, this line is going to make an angle with the positive side of x-axis, y-axis and z-axis as well. So this is the angle. Okay, then we have this angle with which it is making, and we also have this angle with which it is making with the z-axis. I hope everybody is able to imagine. See, we know that the line makes an angle with alpha, beta. So we know this is alpha, correct? This is alpha, this is beta, and this is gamma, right? See, we know this line with z, it is making an angle of alpha, beta and gamma with the x, y and the z axis, correct? So therefore we also know that the direction cosines of this line are what? What are the direction cosines of this line? Direction cosine is equal to cos alpha, cos beta and cos gamma, correct? Yes, they are same as vectors. They are absolutely same as vectors, correct? Now understand one thing, that this line is making two angles with the positive direction of the all axis, with all the axes. It is making two angles. How two angles? See, it is making an angle from here as well, correct? It's also making an angle here with y-axis, and it is also making an angle, z-axis is going to be here. So this z-axis is going to look little weird, but just to understand, it's going to make with z-axis as well, correct? So this line is going to make, so what is happening here, are you guys understanding? This line, it's making what? It is making two angles with the positive side. It has two angles with the positive side of the x, positive side of x, y and z axis, correct? Now due to linear pair, correct, see this, if this is alpha, and because it is linear pair, this will be pi minus alpha, this will be pi minus beta, and this will be pi minus gamma. Are you getting it? So what will happen here? Basically every line we can say, or instead of saying every line, let's say that line L makes two angles with positive side of all axes, correct? Right? Then by linear pair, if one angle is alpha, then the second will be what? It will, by linear pair, can we say it will be, the angles will be what? It will be alpha and pi minus alpha, beta and pi minus beta, and gamma and pi minus gamma, correct? That means what? That means if I have to say that the cos angles of the other side, therefore can I say that cos alpha minus pi minus alpha, cos pi minus beta, and cos pi minus gamma, these are also direction cosines, correct? These are also direction cosines. Yes or no? Of the same line. Yes or no? Yeah, of the same line. Let's say, okay, thus we can say that every line. So what is the statement that we are trying to make here? So therefore, we can say that every line has two sets of direction cosines. Are you guys understanding? Okay. Now, see. So let us put it up again. What are the direction cosines of a line? Direction cosines of the line are cos alpha, cos beta, and cos gamma. What do we call them? We call them as L, M, and N. And the other set of direction cosine that we figured out was cos pi minus alpha, cos pi minus beta, and cos pi minus gamma. Understand one thing, guys, that cos of pi minus alpha is equal to minus cos alpha, correct? Similarly, cos of pi minus beta will be minus cos beta, and cos of pi minus gamma is equal to minus cos gamma, which means what? Which means if we apply this here, we will get this as minus L, minus M, and minus N, correct? So what are the two direction ratios? So have we found out now? Therefore, the two direction cosine sets will be what? They will be, we can write them as L, M, N, and minus L, minus M, and minus N, right? Minus L. Are we clear about this? Correct? These are the two direction cosines. So, two sets, yes, but one set is same as the vector. There are two sets, but one set is same as the vector. So, now on we will consider our line as a directed line, correct? See, this is a line, and if I put an arrow, then this becomes a directed line. Are you getting it? The line which is directing towards one side, and if it is directing towards one side, or if it is directing towards one direction, then it becomes a vector, correct? So a directed line, now onwards we are going to call our line as a directed line, correct? And so this takes us back to chapter 10 again. Whenever we are going to refer of a line, we will consider that as a vector, correct? Every line has how many direction cosines? We can say every line has two set of direction cosines, correct? Every line has two sets of direction cosine. And what are the two sets of direction cosines? Correct, the two sets of direction cosines, one set is equal to first set is equal to L, M, N, and the second set we can say is equal to minus L, minus M, and minus N. And what is this finally going ahead? This is actually the cos theta value, and this is going to be the minus cos theta value, correct? That is pi minus theta that we take, correct? So basically these are the direction cosine, sets of direction. Every line has two sets of direction cosine. Okay, then what about direction ratios? What about direction ratios? Direction ratios, every line has how many sets of direction? We know what a direction ratio is. Are we aware of what a direction ratio is? Direction ratio are those three numbers. What are those three numbers? Direction ratio is A, B and C. A, B, C, which are proportionate to L, M and N. What is A, B, C? A, B, C is proportionate to, ABC is proportionate. Proportionate to what? It is proportionate to L, M and N. How? Such that L by M is equal, it is L by A is equal to, L by A is equal to M by B is equal to N by C. This we have seen in the previous part also, correct? So the direction ratios of a line and a direction ratio of a vector are one and the same. Getting it? All right. Now let us understand what is the relation between this direction cosines of a line. All right. Let's see. All right. Okay. Now let us understand what is the relation between, what do you mean by the relation between the direction cosines of a line? Okay. Remember one thing, that now our line is same as a vector. Why it is same as a vector? Because we are taking this as a directed line. Once you take the direction of the line, once you take a line as a directed line, then this line becomes a vector, correct? We can treat that line as a vector. It doesn't really become a vector, but yes, we can treat that line as a vector. Now, let's say this is our x-axis, y-axis. This is our x-axis. And let's say this is our z-axis. All right. On this axis, we are all aware, we have been seeing this right from the vector lesson, that there is some point here. There is some point here which we call that as a P. P is a point in the space, correct? And there is this line which goes from the origin and which touches P. What do we call this line as? We call this line as OP vector, correct? Alright, as of now I am going to erase this OP vector. We know OP vector. What is OP vector? OP vector is a position vector of the point P. Alright, another peculiar thing that we know, which we have seen, is this particular position vector, it makes an angle with all the positive sides of the axis, and these are what? Alpha, beta and gamma, correct? Those are the direction ratios, or these are the direction cosines of the position vector, correct? All right, so then let's do this. So this is going to be the angles that are created by alpha, beta and gamma. Say this is alpha, this is gamma, this is beta and this is gamma. Correct? Every time when you do the same thing, obviously you'll remember it, because these are the only ratios that we are going to talk whole of the lesson completely, correct? Okay, now so therefore can we say that the direction cosine of OP vector is equal to what? It is equal to cos alpha, cos beta and cos gamma. Alright, and what are the other names? Cos gamma. The other name of this is L, this is M and this is N. So far we are aware about this. Now let's assume that we have to draw a perpendicular from this line. If you draw a perpendicular from point P on the y-axis, correct? That means this distance will be y, correct? Similarly, if we draw a perpendicular on the x-axis, it's going to be a little difficult for me to draw the perpendicular, thoda mushkil hai. Okay, so it's going to be, if you draw a perpendicular on the x-axis, if you draw the perpendicular on x-axis, then this will be what? This will be covering up the distance x. Like that on the z-axis, it will be covering up the distance z. correct? So if we draw the perpendicular, we have a complete right angle triangle here. With that understanding, if we try to write down what are going to be the value of, let's say, cos alpha, cos beta and cos gamma, correct? All right, what will be the value? What is cos alpha? Or let us start with cos beta first. What is cos beta, since we can see cos beta? This is your OP vector. What is cos value? Go to 10th standard trigonometry. Cos value is equal to adjacent by hypotenuse. Adjacent is what you have, y, correct? And what is going to be your hypotenuse? It is the magnitude of OP vector, correct? Right. Similarly, this will also be x by magnitude of OP vector, and this is going to be z by magnitude of OP vector. Clear? All right. Now, the other names, as we know, this is equal to L, M and N. Perfect. Now, let's do one thing. Let's square them. Okay. So, if you take L square, I'm going to draw a line here. All right. Okay, let's see. So let's square L, M and N. So if you say L square plus M square plus N square, what will that give you? That will give you X square plus Y square plus Z square by magnitude of OP vector square. Right? Now, L square plus M square plus N square. What is that equal to? That will be what? We all know what is the magnitude of OP vector. What is the magnitude of OP vector? Magnitude of OP vector is equal to under root of X square plus Y square plus Z square. Correct? So we square this up further. If you square this side, you have to square the other side. Correct? So what will we get here? We will get X square plus Y square plus Z square, and you have under root of X square plus Y square plus Z square, and you have to square this further. Correct? Sorry, I think. All right. So if you square this, that means the root will go away. So you will have, finally you will have L square plus M square plus N square. You get that is equal to 1. This is a relation. It is an extremely important relation. We use this to solve a couple of questions. Okay. Have you understood this? Okay. So basically, this relation that we have figured, this is a relation between the direction cosines of a line. This is the relation. What is the relation between the direction cosines of the line? That the sum of the squares of the direction cosine is equal to 1. That is the relation of the direction cosines of a line. Perfect? Alright. Now let's see what happens to the direction cosine of a line which are passing through 2 points with this understanding. Okay, so we'll figure out, we'll learn everything about the direction cosines gradually, and then we'll also see what happens to direction ratios, and then we will do a couple of sums. I think we should be equipped to solve the sums after we have all the informations, correct? Okay, what are the direction cosines of a line passing through 2 points? Now understand, a line passes through 2 points, but at the same time a line passes through infinite points as well. Alright, passing through 2 points. Alright, that means if we take this is a line, say, alright, then let's say this is line. Okay, this line we are going to have, this is a directed line. So this line is going through A and through B. What are the coordinates of A? Let's say they are x1, y1 and z1, and the coordinates of this are going to be x2, y2 and z2. Correct? Now, see, this is a line L which is passing through 2 points. That means what are the direction ratios of this line? What will be the direction ratios of this line? Okay, if this is a directed line, first of all let us find out what is. We have given an arrow here. We have this as a directed line, and we have said in the beginning that if it is a directed line, we are going to use that line, or we are going to say that this line is as good as a vector, because this is a line in going in a particular direction, and that is why this line is going to act for us like a vector. That will make our calculations extremely easy. So can we say therefore directed line AB is similar as AB vector. Okay, it is not equal to, but it is similar to, we can say it is similar to. Okay, treated as, we can say. Okay, directed line AB. So directed line AB, we can simply say that this is equal to AB vector. And how do we find AB vector? AB vector is going to be x2 minus x1, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Perfect. All right. Now, what are the direction ratios? What are the direction ratios of AB vector then? Therefore, direction ratios of AB vector will be what? A scalar component, correct? Therefore, direction ratios of AB vector. Direction ratios of AB vector are the scalar components which you can see in the vector. What are the scalar components? The scalar components are x2 minus x1, y2 minus y1 and z2 minus z1. Are we clear? Correct? These are the scalar components. Then what are the direction cosines? Direction cosines of AB vector. Direction cosines of AB vector will be x2 minus x1 by magnitude of AB vector. Correct? Then y2 minus y1 by magnitude of AB vector and z2 minus z1 by magnitude of AB vector. Which means what? Which means we can say that direction cosine of a vector is equal to scalar component divided by magnitude of the given vector. Correct? This we can remember it like this, that a direction cosine of a line is equal to, see, listen, technically we are calling this as a vector, but technically this is a line. It is not a vector, correct? It is a line which is passing, it is a directed line passing through 2 points. Because it is directed line, we are assuming that it is a vector. And it's going to be true that way because we are confirming the direction of the line. So this will work out like this, correct? Is this clear? So just remember, in case if you need to use it anywhere else, what are direction cosines of a line? Direction cosines of a line are scalar component. Scalar component divided by what? Divided by magnitude of that vector. Scalar component of the vector divided by magnitude of that vector. Correct? This will give you the direction cosine of a line. Are we clear about it? Correct? Now, some kids might use this side. They can say it is vector AB. Then what about the other kids? The other kid will say, I want to use BA. Oh, that's fine. No worry. It's fine. So we can say, I'm just going to erase this. Okay, you can write it down, note it down in the way. Okay. Now what happens if some kids take this, if some students think that I want to take direction cosine or I want to take the directions from BA. Okay, let's start from direction ratios itself. Okay, what are going to be the direction ratios? If you take the line reverse, okay, if you take it as BA vector, let's from here. Okay, if some kids decide to take it as a BA vector, then what will be the first of all, let us find out what the vector will look like. It will be x1 minus x2 I cap, perfect, plus y2 minus y1 I cap, j cap, plus z2 minus I'm sorry, so used to doing it like this. One second, I'll just, okay, so this is going to be y1 minus y2 j cap plus z1 minus z2 k cap, correct? Okay, so that means what will be the direction ratios of BA vector now? See, AB and BA, finally it's a line, you can count it from any side, correct? So what are going to be the direction cosines, also direction ratios? It will be x1 minus x2 then y1 minus y2 and z1 minus z2. Perfect. Then in that case, what do we have our direction cosines? What our direction cosines are? Direction cosines are going to be the opposite side, correct? This will be x1 minus x2 by magnitude of BA vector. Then this will be y1 minus y2 by magnitude of BA vector, and z1 minus z2 by magnitude of BA vector. So how it is making a difference? So if we say that this is going to give you a positive LMN, then the yellow part will give you the negative LMN, correct? So if this is going to give you L, if this is going to give you M, and if this is going to give you N, then automatically you must understand that this will give you L minus L, this will give you minus M, and this will give you minus N, correct? Because it is going to be the opposite end. But in NCERT, mostly only the positive side is taken. Okay, in NCERT, we always consider the positive, only the AB vector. If we go by the alphabet, and in NCERT, the rule is we only look at the positive direction cosines. Okay, some questions can come if required for a negative direction cosine, but then that's it. We don't have to really worry about it. But yes, we should know about it. We should know how it is understood. I mean, how it is written in case if the question would be like that. Correct? Okay. I hope direction cosine is clear so far. Let's see what happens with the direction ratios. Okay, ये थोड़ा सा extra knowledge, okay, about direction ratios. You can call this as a little extra gyan. Okay, what is the extra gyan? The extra gyan is that if we have a line, if this is your line, okay, on this directed line, we took points A and B. But we can't forget the fact that a line is made out of infinite points, correct? That means we can take A and suppose C. I can take C and D. This can be P, this can be Q. We can pick up any points. Perfect. How many? What are the pairs? We can get infinite pairs, yes or no? So I can have AC, I can have AD, I can have AP, I can have AQ, we can take AB, we can take anything, we can take CD, we can take. So which means what? Which means as many points we are able to pick up, those many direction ratios we will get. You getting it? Every time we pick up a set of points, we will get those many direction ratios. This means what? This means one line, or a line, we can say a line can have infinite direction cosines, direction ratios, correct? Infinite direction ratios, but what? But only two sets of direction cosines, but only two sets of direction cosines. Why only two sets of direction cosines? Array, because the line will make only two set of angles with the positive side of all the axes. No, that is why. Points are infinite, but the number of angles that the line will make with the positive side of x-axis or y-axis or z-axis, that is only going to be 2. That is why only two direction cosines, but infinite direction ratios. I hope this is very clear. Perfect. All right. Okay. Now let's see. So we understood that direction ratios and direction cosine. So let's see. So direction cosine of any line, by now I think all of you know this, that direction cosines of a line, what are the direction cosine of a line? L, M and N. Direction ratios of a line are A, B and C, correct? That means, can we say, and therefore we also know what? We know what? One fact that we are aware, that L by A is equal to M by B is equal to N by C. Perfect. Now, if this is the case, so if, can we say that if this is equal to L by A is equal to M by B is equal to N by C, then can we say that A by L is also equal to B by M is equal to C by N? We can say that, correct? So let us take the second part. Okay, if I say then A by L is equal to B by M is equal to C by N. Let's say this is equal to some value K. What is K? K is a non-zero scalar. Correct? Some constant like we used to say before. It's a non-zero scalar. Okay. That means what? Can I say then A is equal to LK, B is equal to MK, and C is equal to NK. Correct? I hope this everybody is getting it. Perfect. Have we got the value of A, B and C here? I hope everybody is getting it, right? Okay. Now let's see the reverse what's happening. Okay. So it's slightly difficult to draw a straight line like this. Alright. Now let's see the reverse. The reverse is, okay, see, when I say the reverse, meaning now we are going to take L by A. What is the original ratio that we have? What is reverse? Reverse is L by A is equal to M by B is equal to N by C. Correct? Let's say this is equal to lambda. What is lambda again? Lambda is equal to non-zero scalar. Correct? Alright. So, which means, can I say that L is equal to lambda A or A lambda, M is equal to B lambda, and N is equal to C lambda. Correct? Okay. We know one ratio that we saw. Okay, what did we see? L square plus M square plus N square is equal to 1. Let's try to use this here. So what I'm going to do is, we are going to take L square plus M square plus N square. What is that equal to? That will be lambda square into bracket A square plus B square plus C square. Perfect. What is this? This entire value, we know this is equal to 1. Correct? We have already proved it before. This is a relation between the direction cosines of a line. This is equal to 1. So can I say 1 is equal to lambda square by A square plus B square plus C square. That means 1 by A square plus B square plus C square is equal to lambda square. That gives us the value of lambda. Correct? Therefore, we can say that 1 by root of A square plus B square plus C square is equal to lambda. Correct? Let's say this is our 1. Clear? I hope you're getting it, all of you. Alright. Now, this is our lambda. We come back to the values that we have here. What did we take? L by A is equal to lambda. Correct? Now, can we then find out what is the value of L? What is the value of L? So, L by A is equal to lambda. That means A is equal to L by A is equal to 1 by root of A square plus B square plus C square. Therefore, can I say that L is equal to A by L square, So we can say therefore L is equal to A by root of A square plus B square plus C square. Like that we can write down M is equal to, I'm going to go to the next page here because alright. So what did we get here? We got L is equal to a by root of a square plus b square plus c square, like that. M is equal to what? M will be, okay, this can be plus or minus, okay, this is equal to plus or minus b by, why plus or minus? Because we is the square root, no? Okay, it's going to be root of a square plus b square plus c square, and n is equal to plus or minus, no sorry, not root, because it is direction cosine, it can be either plus or either minus, equal to root of a square plus b square plus c square. I hope this is clear. Correct, there is no doubt until here. If you have a doubt, you can go back and you can see what is the um, how we have done the relations. Okay, we are going to do a couple of sums here, and when you do the sums, things will be more clear. Explanation is given to you with an understanding that if you get stuck in anywhere, see, ideally speaking, you can directly use the formulas and you can do these sums. That's not going to be very difficult, but the reason why we give long explanations, or the reason why we give detailed explanation, is because you should understand what is happening and why the condition, why do we have these relations. If you know why the relations are like this, then you can understand the sums better. That is why we do these explanations. All right. Okay, so all right, then let's start doing this question. They are saying that there is a line. Okay, so let's first draw the y-axis, then we have the x-axis, and we have the z-axis. See guys, understand one thing. This question doesn't need a diagram, but we are doing this as a first question. That is the reason I'm drawing the diagram. This question can be done directly. Okay, so if this is a line, understand this is a directed line, so it's going to act as a vector. What are they saying? This line is making a 90-degree angle, 60-degree angle and 30-degree angle respectively with x, y and z. That means this angle is 90-degree here, correct? This is going to be 30-degree, 60-degree, sorry, and this is going to be 30-degree. This is how, this is going to be 90-degree, this is going to be 60-degree, and this is going to be 30-degree. All right, very easy. That means direction cosines are equal to what? Direction cosines are equal to cos alpha, cos beta and cos gamma, correct? That means direction cosine of this line will be what? Direction cosines of this line will be cos 90, cos 60 and cos 30. What is cos 90? Cos 90 is equal to 0, cos 60 is equal to 1 by 2 and cos 30 will be root 3 by 2. What is this? This is equal to L, M and N. This is what? This is one set of direction cosine, correct? This is one set of direction cosines. We saw right now there are, every line has how many? Every line has two sets of direction cosines. Can we find out what is the second set? We know that the second set is going to be minus L, minus M and minus N. What is that going to be? The second set will be what? Therefore, the second set will be 0. It will be minus 1 by 2 and minus root 3 by 2. This is not a part of the question. We will just do it for our understanding. This is the second set of direction cosine, correct? I hope this is clear. Perfect. All right. See guys, this question is typically a 1-mark question. Okay, it's not difficult, very easy. I think very simple to understand as well. The first exercise also has very few questions. They are also not very difficult. I'll give you the important questions at the end of the after we solve these examples, and you will be able to do those sums by yourself. All right. Okay. What is this they have given us? If a line has a direction ratio, that means we have what is given to us? Direction ratios are given to us. What are the direction ratios of a line? It is 2, minus 1 and minus 2. Correct? Okay. That means what is this? This is actually A, B and C. Perfect. Alright. That means what are going to be the direction cosines? What are direction cosines? Direction cosines is equal to scalar component by magnitude of the vector, correct? We just saw this is going to be scalar component by magnitude of the vector. So first of all, we have to find out the magnitude of the vector. Say if these are the lines, that means what is going to be the magnitude of the vector, correct? Okay, that is equal to direction cosines, we can say. Or the other way of doing it is how? If you don't want to do it like this, if you don't want to find out the magnitude of this vector, we can directly do it by using the L, M and N, correct? Direction cosine is equal to L, and we know what is value of L. L is equal to A by root of A square plus B square plus C square. The same thing, but we have a direct formula for it, correct? Alright, then is equal to M is equal to B by root of A square plus B square plus C square, and N is equal to what? We have C by root of A square plus B square plus C square. Let's substitute the values here. What do you get? You get your 2 divided by A square. A square is equal to 4 plus 1 plus 4, that's equal to 2 by root 9, which is equal to 2 by 3. This will going to be how much? This is going to be minus 1 by root 9. The denominators are same, so we can directly write this, and this will give you what? This will give you minus 1 by 3, and this will be minus 2 by root 9, and that will give you minus 2 by 3. This is what? This is one set. What is the second set then? We know how to find the second set. Second set is just going to be the opposite signs, correct? What is the second set? Minus 2 by 3. Second set of direction cosines. This is what? This is second set of direction cosine. Would be plus 1 by 3, and this will give you plus 2 by 3. I hope it's clear. This is very easy. Okay, fine. Let's go to the, if you have to understand this, you can go through the entire sum again, and you can pause this video, you can check what you have not understood. If you need to have any explanations, note them down, you can message me, ask me, and we will solve them. All right, okay. What's the next question? Find the direction cosine of the line passing through 2 points. We have been given 2 points. What is this? So we have to first let A be the point minus 2, 4 and minus 5. Let B equal to the point 1, 2 and 3. Alright, that means the direction cosines are going to be what? We know what are direction cosines. Remember, x2 minus x1 by magnitude of AB, y2 minus y1 by magnitude of AB. Okay, so x2 minus x1 by magnitude of AB vector. We have y2 minus y1 by magnitude of AB vector, and z2 minus z1 by magnitude of AB vector. That's not very difficult. First, let us find out what is AB vector. AB vector will be x2 minus x1, that is x2 minus x1, that is 1 plus, that's equal to 1 plus 2 I cap, correct, plus that's equal to 2 minus 4 j cap plus 3 plus 5 k cap. That means this is equal to 3 I cap plus 2 j cap plus 8 k cap, right? Okay, then therefore what will be the magnitude then? Can we find out the magnitude? Magnitude is simply going to be the square of this, correct? That is the square of the scalar component, 3 square plus, is there anybody who doesn't understand how we are getting it? I hope everybody is paying attention here. So you know how you get this, 3 square plus 2 square plus 8 square. This will give us how much? 9. 9 plus 4. 9 plus 4 is equal to 13, and 13 plus 64, that's equal to root 77. Correct? Okay. We have already found this out. So then can we easily find out the L, M and N? Okay. Therefore, what are the direction cosines? Direction cosines is equal to scalar component, which is 3, by magnitude, which is equal to root 77. Scalar component, which is minus 2, by magnitude, which is minus 77. Scalar component 8 by magnitude, which is root 77. These are the direction cosines. This is one set. What is the other set? This is one set, and direction cosine second set. Let us, what is this? This will be minus 3 by root 77. Then it will be 2 by root 77, and this will be minus 8 by root 77. What is this? This is the first set of direction cosine, and the yellow one is going to be the second set of direction cosine. Correct? This is not asked in the question. We are doing this because we want to be very clear of what it is. Alright? Okay. So they have asked us to find out the direction cosines of x, y and z. Okay, how will you find out the direction cosines of x, y and z? It's very easy, guys. See, let's take this is the y-axis. This is going to be the x-axis. And this is going to be the z-axis. Okay. Now, let us understand. First, let us find out the direction cosines of x-axis. X-axis will make what angle with itself? X-axis will make a 0 degree angle with itself, correct? So let us write down angle with itself, or angle with x-axis. X-axis will make an angle with itself equal to 0 degree. So we know we have to look for what here? We have to look for 0 degree means it's going to be cos 0, correct? This is going to be cos 0. Alright. This will make an angle with y-axis. What kind of angle will it make with y-axis? It will make 90 degree. So this will be cos 90. And it will be angle with z-axis. It will make an angle of 90 degree with z-axis. So this will be cos 90. So now what are the direction ratios? Therefore direction cosines of x-axis. Direction cosine of x-axis will be cos 0, which is equal to 1, cos 0, which is equal to 1, cos 90, which is equal to 0, and cos 90, which is equal to 0 again. Correct? Like this, can we find out the direction cosines of all the angles, all the axes? Correct? Let's find out direction cosine of y-axis now. We will keep the sequence of angles with the sequence of the alphabets, which is x, y and z. So angle with x-axis 90 degree. This is very easy, correct? Perpendicular hai na? Okay. Angle with itself, y-axis angle with itself will be 0 degree. Angle with z-axis, very easy, 90 degree. So I am sure all of you by now know this is going to be cos 90, cos 0 and cos 90 again. So then what is going to be the direction cosines? Can we write down the direction cosines here? Let's write down the direction cosines. Direction cosines are going to be what? Cos, direction cosines of y-axis. What are they? They're going to be cos 90 will be 0, cos 0 will be 1 and cos 90 again will be 0. Like this, can we find out the direction cosines of z-axis? Can I leave that to you all? It's very easy, correct? I'm sure all of you know. Do it by yourself. Direction cosines of z-axis, very easy. You can write down, follow the sequence and you all can do that. Okay, great. I hope so far you guys are getting it. What at least what about 40-50% are you understanding with vectors? Do vectors very well. If somebody is not able to do vectors, then this lesson can be a tangent to your understanding. So it's better that you do vectors and then do this lesson. Alright. If you don't understand vectors, this lesson can be a trouble. Alright. Let's see. Show that the point A, 2, 3, 4, B, 1, minus 2, 3 and C, 3, 8 and minus 11 are collinear. We have done such kind of a sum in the vector chapter as well, where we know that there are multiple ways of showing that the line is collinear. Correct? There are different ways. What are the different ways of showing that the line is collinear? What are the different methods? Different methods of showing that the line is collinear. What are they? First, we can show by what we learnt in this lesson. What is that? That is AB vector is equal to lambda times BC vector, or lambda is a non-zero scalar, we know that. Correct? Here we can show that the points are, we have to show that B is a common point. That we even did in slopes. Remember grade 11 we used to show that the slopes of both the lines are same and B is a common point. I don't know how many of you remember straight lines. We had done this. Or we can show what? We can show that the area of triangle is 0. Any of these three is okay, but because we are doing three-dimensional geometry and we have just learned about vectors, we are going to use this method. So what are we going to do here? Okay, so we have to see that AB vector, we have A and B points given to us. What is A? A is given to us, which is 2, 3 and -4. B is given to us, which is 1, -2 and 3, and C is given to us, which is 3, 8 and -11. What are we supposed to find out from here? We are supposed to find out AB vector and we are supposed to find out BC vector. Once we find that out, I think we should be able to easily solve the question. So let's do that. So what is going to be optimum use of the space that we have? Okay, so let's find out here what is AB vector. AB vector is going to be x2 minus x1. Remember x2 minus, let's do it now. X2 minus x1, that is equal to 1 minus 2, that will give you minus I cap. Correct? Y2 minus y1, y2 minus y1 will give you how much? Y2 is equal to minus 2 minus 3 minus 5. Correct? That's equal to minus 5 j cap, and this is going to be minus 7 k cap. Correct? Minus 7 k cap. Alright, what's BC vector? BC vector, again y2 minus y1. Correct? So that's going to be what? 3 minus 1, that's going to be 2 I cap. Correct? 8 minus plus, so it's going to be plus 10 cap, 10 j cap, and this is going to be minus 11 and minus 3, so it's going to be minus 14 k cap. Brilliant. So can we write down that BC vector is equal to minus 2 inside the bracket minus I cap minus 5 j cap plus, is this, oh this is plus, I think, yes, plus 7 k cap. That means that what is this? This is AB vector, correct? Can I write down therefore that BC vector is equal to minus 2 into AB vector? That means can I say that minus 1 by 2 BC vector is equal to AB vector? Or we can say the reverse. This will imply that AB vector is equal to minus 1 by 2 BC vector. Correct? 1 by 2. Both are the same. Correct? And what is the common point here? B is the common point. If B is the common point, then we can say ABC. Therefore, we can say that A, B and C are collinear. Correct? This finishes the 11.1 exercise. I mean, understanding of 11.1 exercise. You have to try 11.1 exercise yourself, and the important questions in 11.1 exercise is very less questions in that exercise. Honestly, it's going to be 1, 4 and 5. Correct? Till we meet up for the next explanation, please solve this exercise completely. Focus on these three kind of sums, I think, and then the rest of the exercise should be very easy for you. All right, thank you, see you soon, bye bye you.